So let's say that we have 12 weeks to run our tests, 12-week test execution period, and we are in the middle of week 4. Okay, 8 weeks left to go. So what we could do is say, I want to see how I'm doing in terms of running these tests. Excuse me. Am I doing it in risk order? So let's say I've got my test cases and I've categorized them into 5 groups here: very high, high, medium, low, and very low. Okay, so 54 of my tests are very high risk tests, 34% are high risk, 5% are medium risk, 5% are low risk, and 2% are very low risk. Okay. Now this is just reflective of the effort allocation. Now this is the extensives right here. Now we could say, okay, we're 4 weeks into our 12-week test period, so we're 1/3 of the way through. Are we running the tests in risk order? So I look at my tests and I go, okay, the high risk test, what's the current status? 67% of those tests have been run and they pass. Okay? 12% of the tests have been run and they fail. So the remaining approximately 1/5 of the tests have not yet been run. Right? At this point, it's probably the case that for the very high risk tests, almost all of those have been run. Right? But the high risk tests, some of them still not yet run. Whereas if we look at the medium risk tests, only about 15% of those will have been run. 85% not yet run, because we haven't gotten to them yet. Okay? So what I want is a situation where, for the most part, I'm running my tests in risk order, so that basically I start with the tests here and then I move to these. Right? Now, logistics will affect this. So sometimes you will run tests that are slightly lower risk than other tests just because of the logistics. Like a particular test environment is set up, and that environment is needed to run a whole collection of tests that have different levels of risk. But you want to try to run the test primarily in risk order. Okay, clear? Yeah. All right, so we want to monitor, are we running the test in risk order? We also want to report our results based on risk. I'm sorry that the lady who was sitting here who asked about that has stepped out. I hope she'll be able to make it back in here shortly, but she was asking about, can I use risk as a way of making decisions about progress and gating, right? Am I done with this particular phase? Am I done with this particular activity? Yes, you can. There are a couple ways that we can look at this. One is the more detailed project team level, and then the other is a more business and executive level. I'm going to show you both. Now, what we're trying to do with risk-based test results evaluation and reporting is to look at this question of which quality risks have been mitigated and which ones are still unmitigated. Okay? So, at project team level, here's an example of how we could report that. This chart may look a little complicated at first, but it's actually really simple and really intuitive. What we have down here are the quality risk categories. You'll recognize those from that checklist of 24 categories that I gave you before. These are the risk categories where we have identified important risk items during the quality risk analysis. So not all 24 would be listed here, just the ones where we actually identified risks. Okay? And for each quality risk category, we have 2 data sets. The gray bar represents the percentage of tests that have been covered. Okay? So let's say, for example, that there are 100 tests that relate to functionality. What this gray bar is telling me is that about 41 or 42 of those tests have been run. Okay? The white bars represent the percentage of total bugs that relate to that risk category. So let's say that 1,000 bugs have been filed so far in this testing. What this is telling me here is that about 150, 160 of those bugs relate to functionality. Because it's about 15, 16%. You see that? See how to read that now? So what is this telling me? What is this telling us? Well, if you look at functionality, load, error handling, and reliability, if I stack these 4 white bars on top of each other in my mind, you'll see that they stack up to around 50%. You see that? Just kind of mentally go pick this one up, put it up there, and then pick this one up, put it up there, pick this one up, put it up there. It's about 50%. So about half of the bugs that we found relate to just these 4 quality risk categories. And this is no surprise. This is just bug clustering, right? You would expect that that's what you would see. Now notice that for these 4 quality risk categories, we've only run about 40% of the tests. See that? Okay, so these are high-risk areas. Yeah, we found a lot of bugs there, and there's still a lot of testing left to be done, which means we're going to find more bugs there. Yeah. Compare that with interfaces. So interfaces, we found a significant number of bugs. It's the 5th leading quality risk associated with bugs. But we've gotten through most of the testing, almost all of it, 80%. So this risk is pretty well contained, right? Not a whole lot left to find out about that. Operations, compatibility, data quality, performance, security are all kind of medium level risks. They're in the middle of the bug discovery pack, and they're the 40 to 60% tested. Medium risk. Usability. Well, I'm happy with this. Most of the testing is done, and it's not a big source of bugs. Installation, you know, most of the testing is done, not quite as much as this, but it's almost 60%. And it's not a huge source of risk of bugs, so it's not too bad. This is kind of in the low, medium low area of risk. Now, localization, how do I feel about that? That's a concern, isn't it? I haven't done a whole lot of testing there yet, but I've found a significant number of bugs based on the small amount of testing I've done. I probably want to throw some more people at this, huh? Find out if this is actually some bug cluster that I've inadvertently stumbled into. Yep. Documentation, date handling, competitive inferiority. About half tested, not a lot of bugs. So those are low risk. Now you might say, what's other? Other is what you classify a bug as from a risk point of view if it does not relate to any known quality risk. And what I can do then is check and make sure that this doesn't go above 5%. If it goes above 5%, then that's telling me that I've got some significant gaps in my risk analysis. I probably ought to go back and revise my risk analysis. See how to read that? Gives a nice detailed view for the project team of where's the risk right now. Where do we stand on risk? Yeah. Easy. Really easy too. You got a test management system like Quality Center or Rational Test Manager or basically any decent test management tool that does traceability. You're able to trace your tests and your bugs back to the risks that they relate to. You can produce this chart in Excel. Really easy. Okay. Examples of how this chart is produced are on the RBCS website. There are a bunch of Excel spreadsheets you can download out there. Now you can also show similar data like that on the previous slide tabularly in numerical form. I don't know, you know, people have different preferences. I think that the graph is a lot more intuitive and readable than something like this. This is what we sometimes call in the United States a wall of text. Right? It's just boom, here's this big wall of numbers, and you're like, oh, what is all this stuff? And what I found is that people get confused by this and they draw the wrong conclusions. Might be useful to you to have this kind of detailed numerical analysis. I wouldn't show it to anybody outside of the test team. Now, I wouldn't show this to people outside of the project team probably, because this is also a lot of detail, and it could be seen as an invitation by senior management to micromanage you, which you never want to do, right? Unless you are actually in trouble and you want management to help you, don't ask management to help you directly or indirectly, right? So management has a right to know, though, where are we with respect to risk? And so this is how you can do it. Pie chart. So let's say we're back at that 12-week test execution effort I was talking about before. Okay, so at the beginning, right, the pie chart looks like one thing. At the end, it looks like something else. What does it look like? Well, let's say that every risk in our risk analysis, we use a traceability of our tests and their results to classify every risk one of three colors. It's either green, red, or black. Green means all of the tests that are traceable back to that risk have been run and they all pass. So it's green, it's fully mitigated, right? Now, red is a risk where there's at least one test that fails, that maps back to that risk. Now, I know that the Chinese tradition is red is good, right? But so this is the American way of thinking about red. Red means stop. Red means trouble. Red means danger. Okay. You don't have to use red. I mean, you can use another color if that's a better cultural fit, right? But red here means this is a known problem, right? Green means go, right? That's a typical American Western thing. And then black is we're in the dark. Okay, well, it's black, right? So black is any risk that is neither green nor red, and what that basically means is that we don't have any known failed tests at this time, but there are still tests left to run. Okay, so basically, big black pie means lots of unknown risk areas. Big red pie means oh no, lots of problems. Big green pie means yay, we're almost done. Okay, so what will happen is at the very beginning we got big black pie, right? And then as the testing starts to go, what happens is that the red wedge grows disproportionately faster than the green wedge because we're running the tests in risk order. We are deliberately running the test more likely to fail earlier. So the red wedge grows fast, and the green wedge grows slow until you get to about the middle of the testing period. And now we start to get into the less risky tests, and then the tests start to pass and the bugs start to get fixed, and the green wedge drives out the red wedge. And when we get here, notice that we can use traceability to show for the red wedge what are the known failed tests and the tests that are left to be run. For the black wedge, we say what are the known past tests and the tests that are left to be run. And as soon as management says, you know what, there's nothing inside this black or red wedge that scares me as much as delaying release scares me, then you're ready to release. See that? So now we are able to have a conversation with management about releases and project milestones that aren't down in this really complex and difficult to understand thing of like how many tests and how many pass and how many fail and how many bugs and how many fixed and how many left to be fixed. That just confuses the crap out of managers, right? Because that's down in the technical details of what we do as testers, right? You don't want to make managers come into your world and have to understand what you do in order to get information out of you, right? You need to go into their world. What are they worried about? They're worried about this. What could fail in production? Help me understand what could fail in production, right? And this is the conversation that you can now have, right? With one chart. And all you need is traceability. It's really simple. All you need is a test management tool that's got traceability capabilities in it, and you can do this. It's really simple. Okay? Okay, good. So let's go back, take another look at OmniNet. So you have identified project risks. And now what I'd like you to do is go back and try to identify some quality risks. I've got this template here to help you structure this, so it's basically the same as the one you saw from CA. So look at the risk categories, look at the OmniNet requirements, try to identify anywhere from 10 to maybe 20 quality risks. And then when you've identified at least 10 quality risks, assess the likelihood, the impact, calculate the risk priority number. Okay? You want to do the extensive testing based on this table, you can do that. The tracing would just be the requirement section number, right? 321, 315, that kind of thing. Okay? So what I'd suggest is that you spend maybe 10 minutes identifying risks, and then another 10 minutes assessing the risks, and then we'll talk about it. Okay? If you'd like to work in small groups, pairs, triples, so forth, you can do that. If you want to work by yourself, you can do that as well. Okay? Sometimes people find that they need a little hint to get started. So let me give you a couple risks to get started. Kiosk accepts invalid payment method for payment. That would be a risk, right? So you put the wrong currency in, or you put the wrong unsupported credit card in, but it takes it. Okay, so that'd be that. Kiosk does not block inappropriate websites. That'd be another risk, right? It allows the display of pornographic or objectionable websites. Okay, that gets you started. So see if you can come up with at least 8 more, maybe 10, maybe 20, but wrap it up in the next 10 minutes and then go back and assess them, and then we'll talk about what you found. Okay? I think that's a defect, and you can discuss that, but it's not a risk because it's guaranteed to happen. Basically, it's a specified requirement.
So we can say the payment failure is one of the quality risks.
Yes, payment failure. So somebody makes a payment and it fails to go through. Yep. And what did you have that as a likelihood and impact?
I think it's 5.
Huh?
5.
5? The risk priority number is 5?
Impact is 2.
Well, likelihood is 5, impact is 2.
Yeah.
So 10.
Yes.
Okay. Yeah. So you're saying, yeah, this is pretty well established technology, so it's unlikely to break.
Yes.
But if it didn't work, it'd be a problem.
Yep.
Yeah. Okay. Good. That's a good one. Let's see, sir. I think you had your hand up, right?
Yes. It's more towards content control and software updates. It mentions topics about cybersecurity.
Yep.
And talking about sending or receiving viruses and worms.
Yes.
So part of the risk, which I think is the most urgent, there is that cybersecurity testing would definitely be an issue. SQL injections, CCRF attacks, and so on. Because in this local kiosk, you're going to have all sorts of characters using them, and you don't know what they can do. So some cybersecurity software definitions are not always up to date, with the recent case being like WannaCry, the ransomware.
Yeah.
So I would believe extensive testing will be necessary for this kind of public-facing kiosks.
Okay. So the risk is infection by malware, and you believe it would require extensive testing.
Yes.
Yeah, I think that's probably safe to say. Yeah. Okay. Good example. And another example. Anyone?
So we can refer the performance. So if net speed is less than that defined kbps, like 128 kbps.
Oh, so fails to achieve
Yes.
specified levels of performance.
Yeah.
Yep, that's a risk. Yeah, what did you say that was from a likelihood and impact?
It will be 4 and 2. Impact is
4
2.
likelihood to
Yeah.
impact.
So it
Yep.
will be 8 to the broader.
Yep. Okay, good. Good. Yeah, that's a problem if it's slow, because people aren't going to want to pay for it if it's really slow. Right. Yeah. Other examples? Anyone? Yes, sir.
The system starts accepting foreign currencies.
That it's not supposed to accept?
Yeah. If it's in the US, you need to pay using US dollars, but you start paying with rupiah, and it starts accepting it.
Yeah. Yep. Okay, that's a good one. Yes, accepts currencies that it should reject. Yeah. What did you say the likelihood and impact was for those?
I think the likelihood is low, 5.
Yeah.
But the impact is 1.
Okay. It could be a very high impact, but really, that's not likely to happen very frequently in production, right? So while it would be, I mean, if somebody figured it out and spread the word, it could be a big problem. It most likely would be a somewhat unusual case, yeah. So maybe the impact is not a 1, because 1 is like that puts us out of business, right? Yeah. Yeah, each individual incident could be seen as bad, but overall it's probably a marginal thing. So, yeah, that's just an example of what I was talking about before. You want to try to think of when you're trying to assess impact, you want to think of the typical case, not the worst case. Right? The worst case is that all of a sudden people know, hey, I can use some other cheap currency and get time out of it, and they start showing up at all the kiosks and putting rupees into them, and then, we're out of business. But what's more likely to happen is that somebody does it by accident. You see what I mean there with the typical case versus the worst case? It takes some experience with this, but okay, good. So, all clear on project risks, quality risks, assessment of likelihood and impact? Yeah?
Since we are using credit cards and debit cards, the confident information should be confident.
Yes, confidential.
So it should not be a risk. So that will be a high risk on.
Yeah, so leakage of private or
Yes.
personal identifying information, yeah, that's a serious one.
Yes.
Yep, yep. Yeah, there are a good 100 or so risks here in this document, and also if you found defects, I'm not surprised. There are probably 40 or 50 defects in it. It's not unusual when you're doing the risk analysis to find defects. Good, so that's I wouldn't say introduction to risk-based testing, because you got a chance to do some 4 hands-on exercises with it. So I'm hoping that you walk out of here, thinking, yeah, I think I could do this. I think I could use this. We've done this, as I said, with clients around the world. We run this as a virtual class, for example. We ran it for a company that had employees all over the place, including Singapore. Ran the training for them. So just get you started. There is more to learn. So as I said, go to our YouTube channel, subscribe to the YouTube channel, and you'll catch we post stuff out there about once a week on test-related things, and there's a bunch of risk-based testing videos out there, with hours of stuff you can listen to. Some of them quite short on very specific topics, and some of them much longer. LinkedIn, you can connect with me on that if you want. I put stuff out there about every day or so about test-related things. Sometimes it's about risk-based testing. And then our website, as I said, there's a lot of additional resources available for you. Templates and articles and videos of various kinds. And most of those are also on YouTube. Checklists. So there's a lot of additional information there. And as I said, we do offer additional training on this, both live, virtual, and e-learning. So if you decide, hey, my whole team should get this, then let us know. We can help you with that. Okay, good. Any final questions?
Have you ever needed or correlated this
space for the like test destinations?
We do, you mean, can you use risk-based testing as part of estimation?
Yeah.
Yeah, yes, you should actually do this prior to doing the estimate because it's telling you, what to test and how much, right? So yeah, the risk analysis should come before the estimation. Yeah. Yeah, we do an estimation training course where that's part of how the estimate is prepared. Okay, great. Well, it's 1 o'clock, so we ended just on time. Imagine that. And lunchtime, so 1 to 2. If you I gotta establish a connection, right? That's a state-based test, right? This is just checking, how do these different states by themselves affect my app? Aha! What did I do? Parameter name. Where's the space?
Dash.
We hadn't had dashes in there before, huh?
Yeah.
That's weird, but it'll allow the dash in the simple value, but not in there. All right, we'll do that. As I said, this thing can be a little bit persnickety about stuff. Okay, so Wi-Fi frequency. Okay, 2.4, 3.6, 4.9, 5.0, 5.9. Add that to the table. Yeah. And then we'll have Wi-Fi calling. I don't know if that's something you guys use here in Malaysia, but basically, a lot of phones in the US, you can set it so that if you're on a phone call and your cell connection drops, it will automatically route through Wi-Fi. Nice feature there. Of course, it's pretty nice for them to be able to charge you for sending your call over Wi-Fi too. You could be using Skype. So Wi-Fi calling on, off. Now I could have, instead of doing this as enumerated, I could have changed it to be Boolean, right? So I could do that as well, but Boolean, I think it only shows true, false, and I'd rather have the words on and off here. It's up to you though. Anytime you're dealing with a parameter that can only take on 2 values, you can use Boolean if you want. Okay? All right, so there's Wi-Fi calling. Now we do the near field communication stuff, NFC, right, off, on, and connected. Add that to the table. Mobile data. Oops, I always do that. Guaranteed to do that at least once per session. Mobile data, off, on. Add that to the table. And then mobile connection, right? Two G, 2.5G, 3G, 4G. Add that to it. All right, so there it is, right? Yeah. So I say add system. And notice again, it doesn't do the automatic build of the test because it could take a while. So when you add the system or modify the system, you still have to go through that extra step of saying, no, really, I want you to build this for me. Okay, so let's start off with just build the pairs. There you go. Okay. The asterisks here being, up to you. Okay. statistics, notice that there's a fairly significant number of combinations, and not because it's triples, but just there's a lot of factors, and each factor has a lot of options relative to what we looked at before, right? So, lots of combinations. Look at the graph. Looks like that. Right. Smoother and more curve-like than what we've seen before. That's just because of the larger number of combinations. Okay, now some of this stuff, if you look at it, you know, there might be combinations in here that don't make a whole lot of sense. Like, for example, if the Wi-Fi connection is none or off, it doesn't make a lot of sense to talk about, you know, combinations of Wi-Fi frequencies because there's no frequency, right? So generating combinations like Wi-Fi frequency none with 2.4, 3.6, 4.9, and so forth, which you'll all find in here, it's nonsensical. So what we could do is say, okay, well, let's go back over to edit, we'll modify it, we'll introduce a constraint that says that if Wi-Fi connect equals none, oops, that would have been fun, then the frequency is going to just be set at 2.4. Right, so it won't generate different combinations, right? So I add that. Oops, oh, because I didn't put the right. See, sometimes it's helpful and it gives you those kind of hints, and other times it just ignores you, which is not always very nice, but there we go. And we can also say that, well then, oh yeah, none and what was the other? Off. So Wi-Fi connect equals off. We're also going to force the Wi-Fi frequency to be 2.4. In other words, we're basically saying don't bother generating any combinations for this. And you're just going to ignore the Wi-Fi frequency, of course. So we add that. Okay? And we have to click Modify System here. So at this point, those constraints have not been captured. So we click Modify System. And now again, notice, test set out of sync with system. See that? So, yeah, it's helpfully suggesting to me, hey, nitwit, you need to rebuild this. So I'm going to go ahead and rebuild it. I always warn you before it blows out your test set. Okay, so here's what it's generated for that. Okay. It's kind of interesting where if you play around with these parameters, you get a different number of tests. So I do that IPOG or IPOF, now it's 34 tests. IPOG F2, that will ignore the constraints, and now it's back to building without constraints, but that was different than what it was before. We got IPOG B, that also doesn't have the constraint handling, so, and this is huge. So if you decide to get serious about using this thing for, you know, generating actual tests, you probably ought to study what the different algorithms mean. There was I was in the graduate student paper review workshop on Monday, I guess it was. And this is like the big topic of, can we find more efficient pairwise testing algorithms? So this is kind of a known problem that these algorithms are, you know, not especially efficient. right? And so, yeah, you have to kind of study it and then, also plan on just playing around with it. So I went to CSP solver there for that. Notice that didn't change the number of tests. Okay. All right, now, so let me show you the other thing that I mentioned here, which is when I talked about constraints. And I said the other thing that's interesting is this idea of differing relations, okay? Which is, we say, okay, I want pairs of these things, but I want triples of these things, okay? So let's say I go, okay, I want pairs by default. Of all of them. Okay? But let's say I think that those three Wi-Fi parameters, the Wi-Fi connection, the Wi-Fi frequency, and the Wi-Fi calling, those guys, they're quite likely to interact in some funky way that I'm not going to like. So I want to have the triples, all triples of those. Okay? So I add that. And now basically I'm going to create what's called a mixed strength table where I have pairs of everything, pairs of all options across all the factors, right? But I also have triples across three of the factors. Okay? So I go modify system. And again, it says test set out of sync with system. Yes, indeed it does. I go build. Now, this is important because if I don't change the strength here, it will just seemingly ignore what I just told it to do. But you actually have to go and select mixed. And it won't warn you. I think this is some sort of feature or something. At least I think it's a feature that you can put the mixed strength relations in the system and then switch back and forth from having that on to having it off by going from mixed to 2 or mixed to 3 or what have you, right? But the first time you do it, it can be like, wait a minute, what just happened there? The first time I tried to do it, I clicked on build, I tried to build it 3 times, and I was like, why is this not building? And then of course, having tried it 3 times to no effect, I tried the most extreme option, which is reading the manual, which I should have done to begin with. And then in the manual it said, hey, dummy, don't do that. I was like, okay, I am dumb for not reading this first. All right, so now that's got the triples of Wi-Fi connect, Wi-Fi frequency, and Wi-Fi calling. And notice that we have the constraints are being honored there, right? So if any place that the Wi-Fi connect is none, the frequency is 2.4. Whoops, see that? Yeah. We have a tester's choice here though, which is kind of funny. And then off also forces 2.4, but again, there's some of these asterisks here, right? So it's like it's implying that there's choice, but in fact, you're supposed to choose 2.4. Yeah. And then there's the Wi-Fi calling, and again, if it's none or off, then the Wi-Fi calling, I believe, is supposed to be off. I thought we set that up, and then that doesn't look like that took there. I'm probably doing something wrong again. So it's not, notice that I asked for triples, but it's also having to honor the constraints, so that actually reduces some of the triples that would otherwise be created. Why it's creating some of these that for reasons I don't quite understand, I'd have to go in again and study the manual. And as I said, the manual can be a little cryptic. Okay, but study the manual, play with it, you get it figured out. But that's the mixed strength capability, which is handy when you have some parameters that you expect will interact, and then there are other parameters you're like, I'm not supposed to interact, so I'm just going to do pairs. And I could even, with this, go to relations. I can remove that, and I can say, for these guys, I want pairs, but for NFC and Bluetooth, I really don't care that much, just as long as they're represented in there somehow or another, right? So I could do that, modify, build. Yeah, and see, it says, system contains two relations. There are two parameters that lack of relation. So, not real good English, but okay. AX will add default one-way relation for all parameters to build mixed strength. Okay, after generation, AX will set back to original relations. So basically, what that's saying is that for Bluetooth and for NFC, it has the one-way relation, which is just equivalence coverage, right? So it's going to build the table, and you're going to get equivalence coverage of Bluetooth and NFC. The reason it gives you that message is because maybe I forgot. Right? Maybe I just forgot those. So it's defaulting to one way, but it's saying if you want something else for those two parameters, you're going to need to go in and modify the relations table to have different settings for that. And so you can see there's a lot of stuff you can do here that you just can't do with an orthogonal array. See that? All these constraints, you can't do that with an orthogonal array. Different strengths of relations, you can't do that with an orthogonal array. Right? So orthogonal arrays are fine if what you're dealing with is real simple systems where all you care about is pairs and there's almost no constraints on how the options pair up, right? And then you can do the orthogonal array if you want. Though, the only advantage to that is that with the orthogonal array, you may get less tests, but you may not too, depending on the nature of your problem. It's definitely going to be more work. You notice that the process of doing the orthogonal array, I got to find the orthogonal array on the website. I got to download it. I got to import it into Excel. I've got to put the headers on, the factor headers on. Then I got to do the copy or the search and replace in every one of the columns. Then I've got to go through and scan the entire table, all rows, to make sure there aren't any illegal combinations in any of the rows, and make sure that I need every one of the rows, right? Whereas here I just go, okay, here are my parameters. Here's how I want them to interact. I go build, and there it is, right? And if I don't like what it built because I forgot something, I just back out, modify the system, and build it again. As opposed to with the orthogonal array, which if I screwed something up, I'd actually have to start from scratch with the orthogonal array all over again, right? So if I screwed up the search and replace somehow or another, if I'd gotten past the undo window, I'd be like, oh, I can't undo it, so I got to build it again. Okay, so there you go. I think that was it. Oops. So for those of you who might not have been here this morning, just to reinforce this, there's hello. contact info here. As soon as this thing stops doing whatever it's doing, it's just sitting here displaying a black screen and a pointer. I'll show you the LinkedIn and YouTube information. And the YouTube channel, on the YouTube channel, there are some things that are relevant to this. So there's the YouTube channel there. On this YouTube channel, you can find some webinars that talk about pairwise testing and orthogonal arrays, very similar to what we just went through. So if you've got colleagues that you're like, oh, I know this person at work who really should have seen this, then you can send them there and they can find it there. There's also a recorded webinar on there that's a demo of the AXE tool, which is a shorter version of the demo that I just did for you, so you can see AXE in action, as it were. And there's also a webinar there called Myths of Pairwise Testing, which I would recommend that if you're going to use pairwise testing, or you're going to have people use it at work, that you give that a listen, because pairwise testing is great except when it's not, okay? Except when it's a bad idea. And sometimes it's a really bad idea. So, as I mentioned at the offset of this tutorial, that if you're dealing with a system where the conditions or the options are supposed to interact in some way, pairwise testing is the wrong technique for that, because it doesn't have any interaction model built into it. You want to use decision tables and domain analysis for that. So I'd strongly encourage you to give a listen to that Myths of Pairwise Testing, just so you get some ideas of what not to do with it. Because I see a lot of people using it for things, and I'm looking at what they're doing, I'm like, that's stupid. You don't want to do that. That's not going to work. It's going to result in too many tests, but at the same time, it's not going to cover what you think it's covering, which is bad, right? So yeah, that's YouTube. You can connect to me on LinkedIn here, and then on the website, there's stuff like the PowerPoint slides for all the different webinars and so forth out there, other free resources. So that's that. Any questions? No? Okay, well, I was taught early on when I first started giving presentations, nobody ever complains if you're done early. So I'm done early, so you guys don't get to complain. So enjoy the rest of your day. Thank you. Okay, thanks. Thanks very much. Thank you.